All right, so this lesson is looking at electric power and energy for the grade 9s. So the most important thing to keep in mind that most people get wrong is that voltage is not energy. People think it is because you see potential, you see it called electric potential, and we think that means potential energy, but it's actually not. It's the energy each charge has. So if you can think about it like this, these are the two prongs of the thing you're going to plug in. You have high energy electrons on one side with a lot of energy per charge, low energy ones on the other side with a tiny bit of energy per charge. To find out the energy, what the potential is it's the difference in energy the charges have on either side of the plug. So it's the difference in energy per charge, not the total energy. It's how much energy each of the charges has as they flow through the circuit. To actually find the power, the energy used every second, you actually need the voltage and the current, because you need the energy each charge has and how many charges are actually delivering that energy to your object. So the unit for power is the watt. You've got that, you've known that for a while, you just haven't known what it meant. What it means is that 100 watts means you've got a certain number of volts to energy difference across your device times the amount of charges that actually drop off that much energy. So P is the power in watts, V is the voltage in volts, I is the current in amps. That's why we need to find voltage and current, because that's how we get the energy to our device, which is why we build the circuit in the first place. How do we use it? Well, not too hard. Same as the Ohm's law, you just plug things in. Write out what you know. So 10 amps, 120 volts, I want to know power. There's only one equation you're going to have for power. It's voltage times current. So write it out, plug in the voltage, plug in the current, get an answer, and give me a unit at the end. So the unit for power, watts. The power for this hairdryer is 1200 watts, which actually makes it a slightly small hairdryer. Most are around 15 to 1800 watts. But that's a big number. So we typically use something called a kilowatt to look at how much power we're using. Watt for a single device, kilowatt for a lot of devices. So kilo in metric means 1,000. So every time you put a K in front of something, it means 1,000. Like kilometer is 1,000 meters. Kilogram is 1,000 grams. Kilowatts are 1,000 watts. The way you convert from watts to kilowatts is dividing by 1,000. So for example, the last question, we can actually write that instead of as 1,200 watts, we could write that as 1.2 kilowatts. And when we start looking at electricity on a larger scale, you look at kilowatts, not watts, because watts are, one light bulb can be 100 watts. Now, to find the energy, you need two things, because the power is the energy per second. So to find the total energy, or the energy per hour, we want to know how much total energy are we using with this device that we're on for an hour, let's say. So you find it by multiplying the power in kilowatts by the time the object is on for in hours to get a unit called kilowatt hours. And this is how we actually deal with electricity and pay for it. So the energy in kilowatt hours is the power in kilowatts times the time the object is on for in hours. Now, 1 hour is 60 minutes or 3,600 seconds. In fact, converting seconds and minutes to hours is probably the only hard part of this. The good thing is you have a really good tool for doing that. Google will actually translate or will convert everything for you. If you actually put, say, 10 minutes to hour, convert 10 minutes to hours into Google search, it will actually solve it for you. Good thing to remember when you're doing things online. So, what's the energy needed to run our hairdryer for 5 minutes? Well, first we need to convert the minutes to hours. The way we do it mathematically, we divide the 5 minutes by 60 minutes in an hour to find out how much of an hour 5 minutes is, or as I said, you just plug it into a search bar. There's our time in hours. We know our power is 1.2 kilowatts. I want to know the energy. So, energy is power times time. 1.2 kilowatts times 0.083 of an hour gives me 0.0996 kilowatt hours. So about 1 kilowatt hour, 0.1 kilowatt hours. What does that mean? Well, kilowatt hours are what you pay for electricity in. So we measure the cost by how many kilowatt hours of electricity we use. And in Ontario, it actually depends on the time of day. Right now, because of the lockdown, we're all actually in off-peak. Everything is considered off-peak. Um, Normally, because it costs money to produce electricity, when we use more electricity, it costs more. So times where we use the most electricity cost actually more. So off-peak at night, it was about 7.7. It's actually gone up now. It's closer to 12. All these have actually gone up in the last month. But if you notice, in the summer, during the day is actually the highest demand. Why? Because we're running air conditioners. So that's actually why you don't go to school in the summer, is that it costs too much to run the air conditioners, and it's too much of a load on the electricity system. In the winter, the peak is in the morning when people are getting ready to go to work, and at night when we're all making dinner and we're turning on ovens and stuff. During the day actually isn't as much. Weekends and holidays, it's always off peak. So to find the cost, you multiply the energy by the price. So on peak, our hairdryer would be 1.1 kilowatt hours, so about 1.4 cents. But if you ran the same hairdryer on a weekend, it would actually only cost you about half as much, because it would only be the off-peak price times how many kilowatt hours you've used. This is actually why we could save energy. The idea is you can actually save money by saving energy. So for example, with my electric car, it takes 12 hours to charge. I have it set so it charges from 7 to 7. So my car doesn't start charging until 7 at night. It finishes charging at 7 in the morning. So I'm always paying half as much as I would otherwise to charge my car. So what's the application to our ship? Why are we doing this in this unit? Well, every device on our ship is going to need power. It's going to need energy to run. Our batteries, generators, and solar cells must provide enough energy to power that supply constantly. And how we're going to power it is different than how we power things on Earth. We can't just bring oil with us. We can't bring coal. Wind power won't work too well in space. Solar will work until we get far away from the sun. We need energy, and we can calculate that energy by adding up the kilowatts of every device that we have plugged in. We can figure out how much energy we need when we build our rocket beforehand, and we can figure out how to reduce the energy. So this is actually how, before we take off, we could figure out and make sure that we actually have as much energy as we need. Because if we add together the wattage rating of all the devices and how long they're going to be on for, we can figure out how much energy we need to provide. All right, see you next time.